Thank you everybody for joining us. My name is Virginia Batt. I'm the Channel Marketing Manager for Vision Technologies. We're glad that you're with us today for our second to last presentation surrounding the life cycle of a DAS project. So today we're going to be discussing proper DAS deployment techniques during both installation and activation phase of the project. As normal, our presentations will last about 30 to 35 minutes. Your phones have been muted, but if you have questions, please don't hesitate to use the comment box that's on your screen. We definitely want to try to address some questions today, so certainly if you have questions throughout the presentation, go ahead, enter them. We'll be reviewing them. If we don't get to your question, we will make sure that we follow up with you and email you an answer. So the next two slides should look familiar. It's the corporate overview of both CommScope and Vision Technologies who have sponsored this webinar. If you're new to the group and you would like more information on either organization, please email us, send us a note. We'll have plenty of contact information at the end of the presentation. We'd be happy to send you more information, take a phone call with you, anything that we can do to provide more information. So the next two slides, I just want to welcome both of our presenters on the line today. Ron Plekis, who's the Manager for In-Building Wireless Channel Sales for CommScope, and also Rick Baldessari, who is the Solutions Architect for Vision Technologies. At this time, I'm going to turn the presentation over to Ron Plekis, which will run us through the agenda and begin the presentation.
Thank you, Virginia. Appreciate it. Welcome, everybody. Appreciate you sitting in today. So we're basically, today's agenda, we're going to, first of all, kind of give you a summary of what we've covered. Again, we've tried to capture the different phases of a DAS solution, a DAS deployment, and all the parts and pieces. I'm going to address the CommScope requirements in terms of what we're looking for in terms of integration partners. And then we're going to today cover the installation activities that are all key in providing you with the DAS deployment. And that includes project management, dealing with the infrastructure, dealing with the electronics, the hardware equipment, signal source activation, whether it's a base station or a off-air solution, validation, and a very, very key component, documentation. So in the past, just a quick summary, we've talked about, we kind of gave you an entry-level DAS 101. From there, I talked and addressed the topic of partner selection, what, from an OEM's perspective, what are we looking for in terms of capabilities. Then we addressed a needs analysis. We went into system design in some length. The next area was the CommScope DAS family overview, where I basically, the theme of that presentation was one size doesn't fit all. Kind of went through the different product sets and where they fit or do not fit. And today we're going to be covering installation and activation. And our topic for next month will be maintaining equipment. So basically, once the system's installed, then what happens? And we'll also be having a roundtable as well. So, just to be clear, and we've talked about this at some length, the process is very, very important, and it's very, very structured. It requires a specific skill set, and it's certainly not plug and play. And what we're looking for from an OEM perspective, we need a company that has strong RF expertise. The IB-Wave certification is key because that is a document that's required by the wireless service providers. We're looking for companies that have certification on our products so that the warranties go into effect. Understanding the carrier requirements, which is a moving target, continues to change day in and day out. We're looking for a strong wireless service provider relationship and past performance in terms of carrier approvals. The next thing we're looking for in the final slide here is financial and manpower commitment to DAS. We're not looking for companies that basically would go out and hire a third party to do design work and do a lot of outsourcing. We want a company that has all of this intelligence in-house from a technical perspective, from a sales perspective. Again, certification on our equipment. We want to make sure that they've invested in the right testing equipment so that we can deliver the output documents we need to the carriers. And very, very important in the enterprise space is post-sales support. Once that system is installed, most enterprise clients are looking for a service contract. And we want to make sure that our partners not only can provide a service contract, but have the ability through a NOC to actually go through and support remotely that particular product. So I think at this point it would be probably best if I hand this off to Mr. Baldessari from Vision. So Rick, let me unmute you here and we will get this going. Thank you.
Thank you, Ron. Thank you, everyone for joining the webinar today. And so I'm going to talk about the installation process. So, as you know, all DAS solutions, really all wireless solutions, while they are wireless for the users, they do utilize many wires. And the key to providing a good DAS solution is good RF engineering, good low voltage cabling, and really teamwork and communication and trust are the glue that binds everybody together for a good deployment. So what I'm going to talk about today specifically is actually the installation process. And, on the screen are the various different steps and procedures that I'm going to talk about. And some of them, like project management, is really something that spans the entire project. Same with the wireless service provider coordination. That is something that really takes place through all the stages of the installation. So let me start with project management. And as I've said in the past, project management is really the critical piece for a good, successful deployment. And a good project manager is going to be detailed-oriented because, it's the details that are critical, and not following and understanding those details gives you a lot of room for problems and overages in both cost and delayed installation. So some of the things that the project manager needs to do is to make sure that all the stakeholders understand their responsibilities. So having a scope of work and defined tasks for both the cable installation teams as well as the RF teams that are doing the actual work. So everybody knows, what they're supposed to be doing, and to eliminate some of the finger pointing that can take place. Also, as I mentioned, a key feature is communications, making sure both the client knows what's going on, but as well as all the individual teams that are working on the project. But also we need to, if this is going to be like a new building or a building that is being renovated, you need to coordinate with the other trades that are in the facility. And so there's typically, weekly meetings that take place with the general contractor, with all his trades, making sure that, the work is coordinated and people aren't stepping on each other and getting in each other's way. And as the installation takes place, having in-process quality reviews is important to make sure that the work is being done properly, correctly, and that it is being done on time. So the in-process reviews will help the project manager realize if there are delays in the project or if there's going to be cost overruns. And knowing this information earlier in the process allows the project manager to implement, changes and corrective actions to get the project back on track. And, again, the important piece of ordering the materials, making sure that they are delivered on time, that there's a proper place to store the equipment so it doesn't get lost or misplaced, and that the materials can be staged and be ready when they're needed. So one of the first things that take place within the DAS installation is the infrastructure and the cabling. So we need to get the cables roughed in. We also need to get the equipment mounted. If it's chassis-based gear, they're going to mount just the chassis equipment. Or if it's wall-mounted, then, we need to make sure there's plywood to mount the equipment on the walls. And equipment mounting is one of those areas, as well as the in-building antenna installation, are one of those areas where you can get confused on who's doing that. Is it going to be the low-voltage cable provider, or is it going to be the DAS provider that installs those materials and equipment? So this is an example of having a clear scope of work and responsibility tasks, so there's no misunderstanding of who's doing what. Once we have the cable installed, it needs to be properly terminated and tested, and this goes for all the cable, whether it's coaxial cable, the half-inch cable, whether it's single-mode or multi-mode fiber. If there's any twisted pair or copper cables being used, they need to be properly, terminated and tested. Test results need to be really collected after they're done and not waited until the end of the project to try to collect the information for the test results and as-built documentation. So once all the infrastructure is put in place, we need to then, make sure all the splitters and antennas are interconnected together. The next kind of basic phase is doing the interconnection of the DAS equipment. So here, if the chassis have been mounted by the low voltage cabling contractor, the RF engineer needs to insert the various different modules that go into those chassis, need to interconnect all the DAS equipment together, need to connect the fiber infrastructure to the DAS equipment. Once all those connections are in place, then we power up the active equipment and access the system manager. And using the system manager, you need to validate that all the equipment is interconnected properly, and which means you can communicate with it. You can see that there's either red or green lights flashing on the system manager. Those red lights could indicate that the system is not properly configured yet, or it means that you don't have proper communications. A lot of times the fiber pairs could be swapped, and you need to go through and validate that the fiber is correct to turn some of those red flashing lights to green, so you know that the equipment is properly connected. Also, at this point of the process, you want to start implementing descriptive naming for your DAS components. So if the DAS head end is, in the basement in the data center, you may want to make that part of the descriptive name that, it's this is the Verizon module that's going to connect to the Verizon signal source. It's located in the data center. If you've got remote equipment on the 3rd floor or 5th floor, saying that the equipment is on the 5th floor west riser closet, or it's on the 3rd floor east riser closet, is very helpful. So if there's a problem, you look at the system manager and you'll know where the defective equipment is located. So it becomes, a very quick and easy way to start looking for and isolating problems. Once you know the system is connected and operating properly, that's when we start doing some of the on-site RF engineering, and we'll take a continuous wave signal generator and inject the signal at the DAS head end at the frequency modules that will eventually connect up to the signal sources for the wireless service providers. As I indicated a little bit earlier, you're going to have modules that are going to connect directly to Verizon. If Verizon's on the system, modules that will connect to AT&T if they're on the system. Same with T-Mobile and Sprint and possibly any second-tier operators as well. So you interject that test signal, and you do basic and initial system configuration settings to make sure that signal is properly the proper gains are set and the proper conditioning is done to that signal. And then using a spectrum analyzer, we'll go out to all the different antennas that are in the building and validate that there is a signal coming out of all those different antennas. And so we're checking for downlink power at this point. And we want to make sure that we're getting the proper signal strength, downlink power signal strength, at each of the different antennas. And at this point, we also have the ability to go throughout the facility, kind of going to the corners and the areas of the building that are furthest from the antennas and do an initial check of coverage to make sure we're getting the signal strengths that we are expecting. Once we know that the downlink signal is working properly, we then will kind of reverse the process, put our signal generator out on the floors by the antennas or somewhere on the floors to check to make sure that we are getting uplink signal through the system out to the head end. And so now we have the signal generator out on the floors, we have a spectrum analyzer in the head end location, and we validate we've got proper signal coming back. Through this process too, we're also checking isolation to make sure that we're not getting interference on the system inside the building. And also for using a repeated signal, using a repeater or a bidirectional amplifier, we need to check the isolation between the in-building coverage antennas and the donor antenna that is typically installed on the roof of the building. It's most critical that, say if we're on the roof of the building of a 9-story building, we want to make sure that those coverage antennas on the 9th floor are isolated RF-wise from that donor antenna. And so that the signals from the in-building antenna are not propagating out to the donor antenna. If they do, then we'll get a problem called isolation. And isolation is bad. And there are processes where the repeaters will actually degrade their signal strength in order to prevent isolation. If that's not possible, we could actually take down the entire macro cell tower if things aren't properly done before the repeater is turned on and activated. So isolation is a very critical part of the installation process in the RF engineering procedures. As I've mentioned, service provider coordination is something that needs to be done throughout the entire project. And, some of the key steps to the coordination is to make sure that technical approvals from the wireless service provider are received, and working with the service provider and the client to make sure the legal agreements are in place and signed. Once the legal agreements are in place and the system has been properly tested or gone through phase 1 commissioning, then we need to schedule activation dates with the different service providers. And I do mention dates because it will be typically 1 day per service provider. You're not going to have all the providers show up at one time to activate their signal sources. And so if you've got 3 service providers that you anticipate unplugging into the DAS, you'll typically need to schedule 3 separate activation dates. The service providers, have different requirements of their own when they go through activation. Many times they'll come out on site. Other times they may just monitor the system remotely during the activation process. So what is the activation process? Let's talk about what some of those steps are. And so the signal source activation, this is going to be similar to whether I have a base station or small cell signal source or whether I have a BDA or repeater. We're going to connect that signal source to the DAS. We need to make sure we connect the proper frequency from the signal source to the proper frequency module on the DAS. And so typically the DAS has frequency-specific modules, and we need to make sure we line up the 700 megahertz signal source to the 700 megahertz module. Now with the ION-E, that's not as critical because the ION-E provides a wideband and intelligent interface, and it will actually self-configure the frequency band. So once the signal source is connected to the DAS, we need to make the necessary adjustments to both gain, attenuation, and conditioning so that the signal is properly transmitted throughout the DAS. Once the signal source is connected, then we need to do some initial acceptance testing and survey coverage on the floors to make sure that that carrier signals are working properly within the DAS and that we can make phone calls and we can check our data rates. Once all the service providers are connected and plugged into the DAS, that's when we'll do the final acceptance testing, where we'll do a complete survey of the in-building to validate coverage and record the signal strength throughout the entire building in each floor. So this is where we'll confirm that we make and meet the NAIG 85 signal strength coverage through 95% of the facility. If we need to at this point, we'll make any adjustments to optimize the DAS and the performance of the system. And now the final piece of it, and we're not really done until we document what we've installed. Documentation is really just as critical as anything else within the project. As an example, if you can have the greatest, most wonderful DAS, but if you don't know how to turn it on, you don't know how to maintain it, you've got a system that is really subpar. And so documentation is very critical. The documentation should include information such as equipment elevation. So how's all the equipment configured in the racks? What are the specific locations? So what equipment is located in each of the telecommunication rooms? What equipment is located in the data center with the head end? We need to document the serial numbers and the software revisions for this equipment, so you know your starting point. As I mentioned earlier, when you're working with the low voltage cable installers, you want to get the as-built cable pathways and test results at the time the cabling was installed. You don't want to wait until the DAS is operational and functional to go back to your installation team and say, okay, now give me the test results for everything that I've done. Many times months will have passed between when the cabling is installed until when the DAS is finalized. So you want to collect all that information as soon as possible so it doesn't get lost. You need to update any interconnection diagrams, or basically what you'll do here is you will update the IB-Wave documentation from design stage to as-built stage. And so a lot of times I've seen customers provide me with as-built documents, and it's really nothing more than the design documentation that was done prior to installation. So a good DAS vendor will update all the IB-Wave documentation and provide as-built documents, not just design documents. The RF coverage that was done after all the signal sources were activated should also be included as part of the project documentation. Also included needs to be the warranty and maintenance information if there is any maintenance. You know, warranty for some products may be 3 months. For most DAS equipment, it is 1 year. Also, if the customer has purchased maintenance for the system, you know, that needs to be part of the documentation as well. So you can look at that documentation and you'll know whether the equipment is under warranty or under maintenance. And then the final piece is making sure there's contact information, so the client can review his as-built document and know who to contact for what. So all of this information is very critical to have. And another piece that is becoming, you know, just as important is having the actual IB-Wave file itself. So the customer should be requesting from the DAS vendor a copy of the actual IB-Wave file. While the customer may not really be able to do much with that file, it is in his best interest to have it. And in case years down the road, the DAS needs to be upgraded or expanded, you want to have those original IB-Wave files, so it will make it much easier to implement the upgrades or expansion. As an example, Vision is currently doing a maintenance for a DAS system we did not install. That system is, you know, 7, 8 years old. The customer wants to both expand it and upgrade it. In order to get carrier funding or support for this expansion, the service providers want to see updated IB-Wave files. The customer doesn't have these updated, doesn't have the original IB-Wave files, so Vision is going to have to recreate the IB-Wave documentation from scratch based upon some hard copy documentations that we have. And it's, you know, now going to be more expensive for the client because we've got to spend all this engineering labor to recreate a document he should already have in his possession. So for the DAS owners that are on the call, you should start requiring that IB-Wave document to be included as your as part of your closeout packages. So with that, let me move to, you know, a summary of our talk, and, you know, just to reiterate, you know, an on-time and an on-budget installation requires a lot of pieces working together. And, you know, you've got to have a quality engineering to have a quality solution. And, you know, if you got a quality VAR, they'll be using quality materials. And the old saying is you get what you pay for is certainly true with DAS installations. Having a good project manager for logistical details, proactive communications are keys, as well as good teamwork and cooperation are all important things to have when you get your system installed by a quality provider. So with that, I'll turn things over to Virginia, and she can talk about our next session and moderate the questions that have come in during our talk. So with that, Virginia, I'll turn it over to you.
Thank you both Ron and Rick for this presentation. So we haven't seen a lot of questions, but we do have one or two here that we want to address. This one, Rick, actually is about the activation dates and scheduling. So what is the typical time frame between when you schedule the activation date with the wireless service provider and when a customer can expect their actual activation?
So the activation time frame is dependent many times on the schedule of the service provider. I've seen it anywhere from, the service provider will need 1 to 2 weeks notice up to as far as 4.5 weeks, depending on their schedule and their availability. So, scheduling early, makes sense to do, especially if, you're on a time-critical installation schedule.
Okay, and Rick, one more question for you. Someone has asked us if there's a specific format for documentation. Is there something that's kind of, like a universal document, or is there something they should expect?
Yeah, so as-built documents, are there isn't a strict guideline in exactly the format of the closeout documentation. What's more important are the elements that are in it. And as I put up on the slide earlier, having those proper elements of, equipment locations, equipment naming, access to the equipment, as built, cable pathways, is all critical to have. And, the exact, format and in which order they come in is kind of less critical. And it's really, any good engineered solution, if you get 5 different engineers to engineer a solution, you're going to get 5 different solutions. As-built documents are going to be the same. Different people are going to do it differently, but as long as all the key elements are there, then you'll have good documentation.
Okay, and Ron, if you're still with us, I have one question for you. We've been asked if the OEM is involved with carrier approval or who is mainly responsible.
As an OEM, one of the stringent things that we do when we sign up our business partners like Vision is make sure that they have those relationships. So we are not, that is something that is part of their scope of work. We do have situations where we will get companies that are not partners that want to bid opportunities, and then they're asking us to assist them in the carrier approval, and we don't do that.
Okay, I think at this time we're just about out of time. Just want to remind you that our next or last presentation is actually November 17th, so we hope all of you will join us. We're going to be covering post-installation support of a DAS and maintenance, but we also want to open it up as a roundtable discussion and really cover the questions and topics that you would like to learn more about. So one of the things that we'll be doing in the next couple of weeks is taking all of the people that have attended our webinar series, and we will send you a quick short comment box, maybe a short survey, and we'd really like your feedback for that. In the meantime, before you receive it, if you have questions or you'd like to go ahead and send your comments along for our next discussion, please feel free to email both Ron and Rick, and we will compile the questions, and that will be a portion of our discussion for our last webinar. So at this time, we just want to thank you for joining us today. We really appreciate it. We hope you've learned a lot throughout the series, and we look forward to our presentation in November. Thank you.